10-foot tap rule is an extension of the 25-foot tap rule. It applies only to branch circuits that are protected by overcurrent devices rated 300 amps or less. It allows for a 10-foot tap from the load side of the branch circuit overcurrent device to supply a single receptacle or lighting fixture without the need for an additional overcurrent device. If the 25-foot tap rule has already been used to reduce the wire size on a branch circuit for a distance of up to 25 feet, the 10-foot tap rule can be applied to further reduce the wire size for a distance of up to an additional 10 feet. The tap conductor must be connected to the load side of the overcurrent device that is used to protect the branch circuit. Let's consider an example where a 500 amp overcurrent device is used to protect a branch circuit. The 25-foot tap rule is applied to reduce the wire size in the branch circuit for 25 feet. In this scenario, the 10-foot tap rule can then be applied to further reduce the wire size on a tap from the load side of the overcurrent device for an additional 10 feet. There are important notes to consider. The tap conductor must be sized in accordance with the ampacity requirements for the load it is supplying. The 10-foot tap rule does not apply to taps that supply multiple loads or to taps that are part of a multi-wire branch circuit. It is recommended to consult with qualified electrical personnel for specific applications and to ensure compliance with applicable electrical codes and standards. Let's delve deeper into the 25-foot and 10-foot tap rules, focusing on the technical aspects and safety considerations. The tap rules, as defined by the National Electrical Code, or NEC, are designed to provide flexibility in electrical installations, allowing for the reduction of conductor size in specific situations without compromising safety. Understanding the precise conditions under which these rules can be applied is crucial for any electrical professional. Firstly, let's examine the 25-foot tap rule. This rule permits the use of conductors with a lower ampacity than that required for the branch circuit, provided that certain conditions are met. One primary condition is that the tap conductors must have an ampacity of not less than 1/3 of the overcurrent device protecting the branch circuit. For instance, if a branch circuit is protected by a 100 amp overcurrent device, the tap conductors must have an ampacity of at least 33.3 amps. Secondly, the tap conductors must terminate in a single overcurrent device that will protect the tap conductor from overcurrent. This overcurrent device must be rated no more than the ampacity of the tap conductors. This ensures that the tap conductors are adequately protected against any fault currents. Thirdly, the tap conductors cannot exceed 25 feet in length. This limitation is in place to minimize the potential for voltage drop and ensure that the tap conductors can safely handle the load. The conductors must be protected from physical damage, often achieved through conduit or other approved methods. This protection is critical to prevent damage to the conductors, which could lead to shorts, ground faults, or other hazardous conditions. Now let's turn our attention to the 10-foot tap rule. This rule allows for even shorter tap conductors under more restrictive conditions. A key requirement is that the overcurrent device protecting the branch circuit must be rated at 300 amps or less. This limitation is in place because smaller overcurrent devices generally protect circuits with lower fault current potential, making the shorter tap more acceptable from a safety perspective. Another critical condition is that the tap conductors must have an ampacity of not less than the calculated load. This ensures that the tap conductors can safely carry the intended load without overheating. The tap conductors must not exceed 10 feet in length and must be enclosed in a raceway. The raceway provides physical protection for the tap conductors, safeguarding them from damage and reducing the risk of electrical hazards. Tap conductors must terminate in a single overcurrent device rated no more than the ampacity of the tap conductors or to a transformer. The tap conductors must supply a single load such as a single machine, appliance, or luminaire. This restriction is in place because the 10-foot tap rule is intended for very specific, localized applications rather than for supplying multiple loads. Now, addressing the specific question of using the 10-foot tap rule at the end of the 25-foot tap rule, it is technically permissible under certain conditions but requires careful consideration. If the 25-foot tap rule has been correctly applied, reducing the wire size from the main branch circuit, and the termination point of the 25-foot tap does not accommodate the final load connection, then the 10-foot tap rule can be invoked to further reduce the conductor size for the final connection to the load. However, the overcurrent protection requirements must still be met. This means that the overcurrent device protecting the initial branch circuit must be rated at 300 amps or less to qualify for the 10-foot tap rule. The reduced conductor from the 25-foot tap must terminate at a distribution block or similar termination point before the 10-foot tap begins. The tap must be from the load side of the overcurrent protective device. When applying both rules in sequence, it is vital to ensure that each tap meets its respective rules requirements independently. The 25-foot tap must comply with its ampacity and length restrictions, and the subsequent 10-foot tap must also meet its own stringent conditions. Remember that the 10-foot tap cannot supply multiple loads. It must supply a single load. It is also essential to consider the cumulative voltage drop across both tapped sections. Reducing conductor size increases resistance, which can lead to voltage drop. Excessive voltage drop can cause equipment malfunction, inefficiency, and potential damage. Calculations should be performed to ensure that the voltage of the final load is within acceptable limits. When working with tap rules, it is always advisable to consult the NEC directly and to seek guidance from a qualified electrical engineer or inspector. The NEC provides detailed information and specific requirements for tap rules, and interpretations can vary depending on the local jurisdiction. Electrical codes are updated regularly, and understanding the latest revisions is essential for safe and compliant installations. Furthermore, consider the practical implications of using multiple tap rules in series. While the NEC may permit such configurations under specific conditions, the complexity of the installation increases the risk of errors. It is crucial to maintain clear documentation of the design, including conductor sizes, ampacities, overcurrent protection, and voltage drop calculations. Thorough documentation can aid in future maintenance, troubleshooting, and inspections. Moreover, be aware of the potential for harmonic currents in nonlinear loads. Harmonic currents can increase the current flowing through conductors, potentially overloading them even if the calculated load current is within a conductor's ampacity rating. If harmonic currents are present, the conductor size may need to be increased to account for the additional current. Additional safety measures should be implemented when working with electrical systems. Always de-energize circuits before working on them and verify the absence of voltage with a reliable testing device. Use appropriate personal protective equipment, or PPE, such as insulated gloves and safety glasses. If the work involves elevated locations, use appropriate fall protection equipment. Double-check all connections to ensure they are tight and secure. These connections can create hotspots, leading to overheating and potential fire hazards. Always follow the manufacturer's instructions for installing and terminating conductors, overcurrent devices, and other electrical equipment. Ensure that all equipment is listed and labeled for its intended use and that it is installed in accordance with its listing. When in doubt, consult with a qualified electrical professional. Electrical work can be dangerous, and it is always better to err on the side of caution. Ignoring or circumventing electrical codes can have serious consequences, including electrical shock, fire, and property damage. Let's delve into a practical example to further illustrate the application of the 25-foot and 10-foot tap rules. Suppose we have a 480-volt, three-phase branch circuit protected by a 200-amp overcurrent device. This branch circuit supplies power to a piece of equipment located 30 feet away from the panel board. The equipment requires a 60-amp supply. To reduce the conductor size, we can apply the 25-foot tap rule. According to the NEC, the tap conductors must have an ampacity of at least one-third of the overcurrent device protecting the branch circuit. In this case, one-third of 200 amps is 66.6 amps. Therefore, the tap conductors must have an ampacity of at least 66.6 amps. We can select a conductor size that meets this requirement. For example, According to NEC Table 310.16, a number 4 American wire gauge, or oak, copper conductor with a 75°C insulation rating has an ampacity of 70 amps, which is sufficient. The tap conductors must terminate in a single overcurrent device rated no more than the ampacity of the tap conductors. In this case, we would install a 60 amp overcurrent device at the equipment location to protect the tap conductors. The tap conductors cannot exceed 25 feet in length. In this example, the distance from the tap point to the equipment is 25 feet or less, so this requirement is met. The conductors must be protected from physical damage. We can run the tap conductors and conduit to provide physical protection. Now, let's say that the equipment has a small control panel that requires a further reduction in conductor size for the final connection. We can apply the 10-foot tap rule to further reduce the conductor size for the final 10 feet. According to the NEC, the overcurrent device protecting the branch circuit must be rated at 300 amps or less. In this case, the overcurrent device is rated at 200 amps, so this requirement is met. The tap conductors must have an ampacity of not less than the calculated load. The equipment requires a 60 amp supply, so the tap conductors must have an ampacity of at least 60 amps. The tap conductors cannot exceed 10 feet in length and must be enclosed in a raceway. In this case, the distance from the tap point to the control panel is 10 feet or less, and we can run the tap conductors and conduit to meet this requirement. The tap conductors must terminate in a single overcurrent device rated no more than the ampacity of the tap conductors. We can install a 60 amp overcurrent device at the control panel to protect the tap conductors. The tap conductors must supply a single load such as a single machine, appliance, or luminaire. In this case, the tap conductors are supplying a single control panel, so this requirement is met. By applying both the 25-foot and 10-foot tap rules, we have been able to reduce the conductor size in 2 stages, optimizing the electrical installation while ensuring safety and compliance with the NEC. Remember, this is just an example, and the specific requirements for tap rules can vary depending on the jurisdiction and the specific application. It is always essential to consult the NEC and to seek guidance from a qualified electrical professional. In conclusion, the ability to combine the 25-foot and 10-foot tap rules offers flexibility in electrical design, enabling optimized conductor sizing and cost-effectiveness. However, it demands a thorough understanding of the NEC, careful attention to detail, and a commitment to safety. Always prioritize compliance with applicable codes and standards, and never hesitate to seek expert guidance when needed. By following these guidelines, electrical professionals can ensure safe, reliable, and code-compliant installations.